Hi, my name is Lee Crow, and welcome back to my Networking for People Who Could Care Less series, Part 2. If you haven't seen Part 1, please go back and take a look at that. It shows you some really basic IP address and subnet ideas. If you're new to this, please go back and take a look at that video first. It's pretty short. In this video, I'll be covering configuring a host for an IP network and doing that manually versus automatically, and typical ways to manage your IP addresses. So what information is needed to configure a host on a network? What does my computer, for example, need to have configured on its network card and its IP settings in order to communicate on the network? Well, first of all, you have to have an IP address and a subnet mask. Those two together will define the actual subnet that the computer belongs to. Next, you'll need a default gateway, and this is optional. And I say this is optional because if the computer or the host that you're putting on the network doesn't need to communicate with any other device outside of that subnet, then you don't need a default gateway. If you just want to communicate with devices on the same subnet that you're placing your computer on, then the default gateway is not needed. The DNS servers, again, this is optional. You typically on my Mac here, I will configure one or more DNS servers, and this is DNS dynamic name system. These are servers that are all over the internet. I even have one here at my house on my Linksys router. And what they do is they allow my computer to translate IP addresses to names, and it makes it easier for the human to reach other devices or even websites, for example. So when I type in www.google.com, well, the internet doesn't, as far as from a communication perspective, doesn't know what that is. That gets translated to an IP address so that your computer can then go and find the server that's in your region for Google. So the automatic configuration. I'm going to use my home setup as an example. My Mac is set up so that its IP address is configured automatically, and that makes use of a service called the Dynamic Host Configuration Protocol, or DHCP. This service can be running on a server. It's typically in an enterprise environment, and it will be running on a server, a routing device, where at home here I have the DHCP service running on my Linksys router, or it could even be configured to run on a workstation. Really anything that's on the network can conceivably be running the DNS service, but it's typically a server or routing device. And DHCP is used to actually configure the host, in this instance my Mac, with the IP address information that it needs. So on my router here, my Linksys, the DHCP service is running. You can see that my router's IP is 192.168.254.1, and I have a 24-bit subnet mask, and that's indicated by the 255.255.255.0. So if you remember from the previous video, my usable IP address range here on this particular subnet would be 192.168.254.1 all the way to .254. So in my router settings, I have DHCP server enabled. The starting IP address is going to be 254.100, and I have a maximum number of users of 50. And this is just the default settings out of the box. I can change all of this. But what this is telling me that I have, basically, if I plug up 50 devices into my network and they're all configured for DHCP, then device number 51 that I plug up is not going to be able to automatically have its IP address settings configured by this DHCP service. And again, I can change all of that. So the IP address range that this service will hand out at my house is going to be 192.168.254.100 to .149. So And really, that's about it. So, and this service, the DHCP server, can also hand out other values. It can hand out your DNS, your DNS IP addresses, or the DNS configuration for your hosts, and all of that. We discussed DNS earlier in this video, and a lot of other variables can be handled by a full-blown DHCP server, but typically it's going to be the IP address, the subnet mask, the router IP address, and DNS, in for example, my home environment. And again, if you remember back from the last video, my brother has inherited a fairly simple network setup, so I'm tailoring these videos for his environment as well, keeping it simple. Now, here is an automatic configuration example. This is from the perspective of my Mac. So I went into the network settings in my Mac, and if you look at the TCP/IP tab, it configure version or IP version 4 using DHCP. So really, that's all I need to do on my Mac in order, since I have my DHCP server set up, in order for my Mac to get on my network, get an IP address with all the parameters that it needs to communicate on the network and to the internet. And you can see that I do have an IP version 4 address that's within that range that we noted on the previous slides. The subnet mask is a 24-bit, and my router here, that's actually the parameter I called default gateway previously. That's going to be the 254.1. And my DNS server was automatically configured to 15.1, and that's actually the device on the outside of my router that that is provided by my internet service provider, and all that was configured automatically as well. So for manual configuration, for all these parameters that we just went over, in a manual configuration, the network administrator would manually configure the PC or Mac or switch or whatever with the IP address, subnet mask, default gateway, and DNS servers. And here, going back to my Mac example that I'm on now, you can see that I've just changed the configure IP version 4 from DHCP to manually, and then all the other fields light they light up so that I can go in there and manually change those myself. And I can add DNS servers as well. So IP address management. Within a subnet, there are typically a mixture of manually configured IP addresses and DHCP assigned IP addresses. So, for example, you've seen here that in my home network, I have the 192.168.254.0 network. But so basically all IP addresses within the usable range of IPs in my subnet are excluded from DHCP, with the exception of the 102.149. Now, so all those excluded IP addresses in the range are IP addresses that are candidates for me to manually assign to other devices on my network. So they can still be used, it's just that DHCP will not hand those excluded IP addresses out to a device that requests a configuration via DHCP. Okay, so typically in an enterprise environment, you'll have a full-blown DHCP server. So your DHCP scope would look something like this. If your subnet was, and we're assuming again, a basic 24-bit subnet mask. If your subnet was 192.168.1.0, so your usable IPs would be 1.1 to 1.254, then your DHCP scope would define the complete range. And then you would have exclusion ranges for IP addresses that you don't want to be handed out manually, or automatically, sorry. So when you do that, your available IPs from a DHCP perspective become, in this example, 1.51 to 1.254. So what's the deal with the exclusion range? The exclusion range, those will be IP addresses that you have reserved for devices that need a static IP address and a manual configuration. And now there are a couple ways you can handle that. You can configure a device with a static IP address via manually configuring the device, like we discussed previously, and you know, in this case, you would use an IP within the exclusion range that we've defined, an available IP within the exclusion range that we defined. But another way to do it is by use of DHCP reservations. So a DHCP reservation would actually be, you would define that within your DHCP server, and the IP address would be in the range of available IPs. It's just that you would basically say, hey, this IP address, we want to associate it with a particular device, and that's typically done by the MAC address. Google that if you don't know what it is, but it's typically an IP address to MAC address relationship. So the DHCP server remembers, okay, this device on my network that has this MAC address, it's going to get this IP address, and it can be configured. The device can be configured for to obtain its settings automatically via DHCP. That's okay, but it's always going to get that same IP address. So it's kind of like the same method or the same idea as a static IP address or a manually assigned IP address. It's just that you're letting the DHCP server handle that. And here in my router, you can see that this is where I would configure IP address reservations if I wanted to. So my Mac, it has an IP address of 254.132, and then it shows my MAC address there. The MAC address is just a hardware address specific to the vendor and the NIC, the network card that's in my Mac. So if I wanted to here, I could say, okay, I want to select that, and I want to make sure that it always gets 254.132 or even another IP address, and I will basically add that to my list of IP address reservations, and I can change it to be another IP address if I want to. But that will just ensure that my Mac always gets the same IP address with the reservation, and I don't have to do anything, or the user wouldn't have to do anything from their perspective. You know, typically a workstation is set up for DHCP, so as long as that reservation's in there and the workstation is set up for DHCP, it's always going to get the same IP address. This concludes networking for people who could care less but need to know a little bit, part 2. If you have any questions or comments, please leave them below and I'll try to respond.